and competent person certification. And just like Mr. Steve Heiss said, this continues to be top of list with regard to citable offenses. And of course, we heard the different employer sizes, but this is something that many of us have seen different forms of fall protection training, but it's always important to make sure that we're on point and doing the best we can do to educate and get that information out there to make sure folks are protecting themselves when working at heights. Who will be giving this presentation today is none other than Kevin Dennis, who is the owner and trainer of Work at Height. And Kevin, we thank you so much for joining us today and giving us this presentation. I'm going to go ahead and turn the floor over to you.
Great, thanks a lot, Rhett. I'm gonna turn my camera off here once I start the presentation, so it's not distracting at all. Can everybody hear me okay?
Yes.
Excellent. Thank you so much. All right. Like Brett said, my name is Kevin Dennis. I'm going to be your presenter here for this session. As you can hear by the people that were presenting, falls continue to plague not only Washington State, but every industry. I want to thank the Safety Summit for giving me the opportunity to present. My contact information will be available here at the end of the session. And there's a lot of information to talk about on this. Although the session is titled, Fundamentals of Fall Protection Systems, WAC guidance, as well as competent person, that's too much content to cover in a 30-minute, 40-minute block. So I am available for webinars, meetings, site visits, whatever you need to get the word out to increase the awareness and the protection of people that work up at heights. So feel free to ask a lot of questions. Like I said, my name is Kevin Dennis. I'm the owner of Work at Height. Established it post-COVID after being laid off for my day job. In 2022, I've been in fall protection since the mid-90s, starting out in southern Alberta, Canada, as a few people have pointed out due to my accent. Since that time, I've evolved to the vice chair of the ANSI Z359 committee. I'll probably be the chair here after the current chair's tenure is completed. I also have a position as a technical service representative for Werner Fall Protection. I'm a retired SPRAT Level 2 rope access technician, and I'm the author of the Work at Height Guide for Fall Protection Professionals. So I have got a lot of useless information for you to share about fall protection. Like people said on the session, nobody knows it all, but I know enough people that whatever questions I don't have the answers to, I can help you out. So before we get underway, I kind of showed my cards there. I advanced the slide too far, but I want to talk a little bit about what is the greatest challenge in regards to fall protection. We heard already earlier that there's been 9 fatalities in the construction industry in Washington State. And when you look at the country as a whole, there's usually 700 to 800, 10 to 20 people per state in a year that unfortunately pass away due to a fall from height. So in my time, I always try to tell people what is the greatest challenge administering fall protection for your site, and it's always the same thing for every company, every organization, in every industry. It is not the regulation, it is not the equipment, which a lot of people tend to focus on. It's something that I call as the greatest challenge. So to prove this point, if you would just take a moment right now and reflect into your past. When you were at height without fall protection, it could be recreating, it could be on the roof of your house, it could be at work, but select that moment when you were up in the air and you remember that, by gosh, if I fall, I'm in trouble. I'm either dead or I'm going to be seriously injured if I fall. Okay, so just take a moment and find that time in the past when you recall the time of the year, the job you were doing, how high you were, the risks that you took, or whatever details. But then ask yourself, why did you do it anyway? For classes that I conduct, I actually have people write down all of the reasons. But why did you personally take that risk? Okay, and without talking to everybody and finding out your examples, I can almost guarantee you that that your motivations for doing that job are going to be one of these that are listed here. Time. Fall protection takes time. I got to set an anchor, I got to put a harness on, I got to find the equipment, et cetera, et cetera. That's usually everybody's number one reason why they took that risk. The odds, people aren't going to fall. Yes, we take a look at the statistics, and just using the recent one that was said here on the session, we had 9 construction-related fatalities. You know, in roofing alone, there's over 4,000 registered businesses in Washington State. And if each of those have, 4 or 5 employees, we're up to 20,000 some people just in roofing. So out of those 9 fatalities in construction, if a half dozen of them were roofing, the odds of a serious fall happening to somebody over the course of their career is very, very low. So that's another barrier, is I'm confident in what I'm doing, I'm very skilled, I'm going to be careful, I'm not going to fall, because the odds are in your favor. Another one, number 3, which is usually the most prevalent, is the person wants to be a good employee. It's worth the risk. It's a short-time job. I want to be known as a get-it-done type of employee. I want to help out my supervisor, my manager, my boss, my employer. And it's worth stepping across that scaffold, or going over the ridge of a building, or off the side of a tree, or whatever the situation may be. They want to be known as a good worker. And other ones, fall protection takes time and money. For some people, they didn't know any better. Some people, this is the way it's always been done. It's just an acceptable risk. It's part of the job. For some people, it's peer pressure. They want to get in with a group, or again, be known as the good employee. And for some people, it's just a lack of resources. They know that they need an 80-foot lift, but it's better to find some other way to go than rent the lift. They just might not have the resources to do it. So the greatest challenge for every organization and every industry is breaking through these barriers. They're cultural, they're behavioral, and the totality of all of these little barriers often lead to the person or organization, not seeing value in fall protection. So your greatest challenge, and although I'm going to transition here into, DOSH requirements for fall protection systems and competent person definition, those are not your biggest challenge. Reflect on your organization, and your greatest challenge is to convince yourself, or your management, or your president, or whoever it is, to apply fall protection all the time, every time. That is by far and away every organization's challenges. And once you break through that, everything else becomes easier, because people believe in setting that anchor, and they believe in getting the right gear and buying quality equipment, and et cetera, et cetera. Everything kind of falls into place if you can get over this cultural hurdle. Because the frequency of falls isn't that common. They're devastating, they're horrible when they occur. The consequences of a fall are very damaging. But the truth of the matter is there's usually more drownings than there are fatal falls. There's much more car accidents. When you enter into mental health and violence in the workplace, those are higher priorities than fall protection. So the frequency of these falls doesn't play into it doesn't benefit as much. So an exposure to falls is incredibly common. I often tell people that before a worker comes to your employment, as a person grows up through their teen years and starts entering into the workforce, they have been exposed to fall hazards thousands and thousands of times before they get to you. So it's quite a shift to take a new employee or employee from a different industry, where the solution to protecting themselves is being careful, being aware, being confident in their skills, and now throwing a harness at them or changing it. Cultural barriers and behavioral barriers are a greater challenge than the technical aspects of fall protection. So I always try to preach that a little bit at the beginning of all of my sessions, is that's always the challenge. Okay. So moving into the specific content here for today, I wanted to talk about the DOSH requirements for fall arrest systems as well, and link that or connect that to the competent person definition and requirements. I cannot go through the entire unified rule for fall protection, so I'm just going to kind of start at the foundation level. So dealing with a fall arrest system, all fall arrest systems have two basic mechanisms of injury. Okay, there's really only two things that can hurt somebody in a fall, and that's the force, and then second is contact with a structure or contact with a lower level. So what I mean by force is, you've all heard the phrase, it's not the fall that kills somebody, it's the sudden stop at the end, and it's a comical way of saying it, but that's the energy, that's the force. When I have a 200-pound person falling 5 feet, 6 feet, they're building up energy, kinetic energy, and that energy has to go someplace. Okay, so it's that force, this energy that compresses spines and separates organs from arteries and dislocates things, or if somebody lands on the ground, that's what breaks the leg or whatever. So force, we have to manage this force. And then the second thing that can injure somebody is contacting with a lower level. So as we talk about requirements and a competent person, these to me are the first two starting points for all of the people within your fall protection program. So, and this also aligns with two of the most important DOSH requirements, 296, 880, 423A and B, which say you have to limit the force to less than 1,800 pounds on an employee, and you shall not contact a lower level. So for me, whenever I conduct competent person training or awareness training or whatever, this again is kind of the starting point, is how do we manage both of these issues, force and contact. So force can only be decreased or managed by manipulating one of three things. We can decrease the weight of the falling object, we can decrease the distance of that falling object, or we can increase the deceleration distance. Okay, so the falling object is obviously the person. Okay, the distance they fall is related to the equipment they're using and where they're anchored, and then the deceleration distance also relates to the equipment that they're using. So when we look at those three variables, weight, distance, and deceleration, we have very little influence over the weight of the worker. People are going to weigh what they're going to weigh, okay? But a 280-pound person is going to generate more force or more energy if they fall the same distance as a 150-pound person. Pretty straightforward, okay? We also don't have much influence over the anchorage location. Anchorage location is kind of dictated by the environment in which you're working. Again, talking about residential construction or roofing, the only anchor that has any merit is going to be below our feet, whether that's the ridge, the truss underneath the sheeting, or a ground anchor, door jamb vehicle, whatever it is, the anchor location is going to be lower than what we're working. So we're bound by the environment in which we're working when it comes to anchorage location. The greatest benefit that we have to reduce the impact force on a person is the use of the equipment and energy absorbers. So shock absorbers on lanyards, shock packs on personal SRLs, internal or external energy absorbers on SRLs. That's the part that really manages this, bringing this arresting force down, is the inclusion of that energy absorber. So I've got a little video here. Hopefully it plays for you. Oh, there we go. So the weight, hopefully that's not choppy for everybody. The weight is the falling person. Once that equipment engages, that's when our free fall distance ends and the deceleration begins. And the deceleration distance was the entire tearing of that shock absorber there. It's that slowing down, that braking action, that deceleration that actually saves the person from these high impact forces. So energy absorbers add deceleration distance to all fall events. The distance that the energy absorber deploys varies according to how much the person weighs and how far they fall. So this is a little chart. If I have let me back up a little bit. One of the greatest misconceptions about energy absorbers is that people believe that they fully deploy all of the time. When we are estimating clearances, we assume full energy deployment. When you look at the label, it gives you the maximum length that it can deploy. But in reality, that shock absorber only deploys the amount that's needed. So what I mean by that is if I have a 130-pound person and they only free fall 2 feet, I'm only going to rip through 4 inches of that shock absorber. Okay? Obviously, as the distance increases, there's more energy in the fall, and the shock absorber deploys a greater distance to handle the energy. Okay? So shock absorbers will not deploy their full distance unless you're at the maximum free fall distance and the maximum weight. Okay? So the neat thing about energy absorbers, though, is that all of these numbers in the graph, the force on the person is the constant. Okay? This is a shock absorber that deploys with an average of 850 pounds. So what the shock absorber does is it makes that 300-pound person and the 150-pound person equal in regards to force. That 300-pound person falling into this SRL, due to that shock absorber limiting the energy or dissipating the energy and limiting the force on the worker and the anchor and the equipment to 900 pounds, it's only going to be 900 pounds on that worker. Okay, a 150-pound person falling into the same equipment is also going to be exposed to 900 pounds. They're just going to deploy this less. So what the energy absorbers provide for us, number one is it keeps the worker's body from breaking. And then number two, it also ensures compliance. Okay? If you are buying ANSI Z359 compliant equipment, all ANSI equipment will have an arresting force in the area of 900 pounds or 1,350. Okay? So you really don't even have to calculate force. You don't have to do any force over time calculations. All you have to do is use the equipment correctly and make sure that the worker weight is within the capacity of the equipment. Okay? So to ensure the safety of the individual and to comply with DOSH, at least in regards to force, a person just simply has to use the equipment correctly. You know, all ANSI equipment has a capacity of 130 to 310 pounds. There is specialized equipment, and the manufacturers have conducted testing on all this equipment to go above that range and below that range to still comply with injury thresholds as well as DOSH requirements. So to handle force, it's all about the equipment. So if I have a person that's out in the field and they're using a harness and a lanyard, I look to the energy absorbing component. What is the maximum weight of the user? And then what is the maximum free fall distance? And as long as I'm within that capacity, I know the shock absorber is going to work for me correctly. So that handles one of the mechanisms of injury as well as complies with the most basic of DOSH requirement. So the other mechanism of injury is contact with a structure. What do you hit during that fall path? Or how far is the equipment going to let you go so you don't contact a lower level? So everybody calls this clearance calculations, estimating system performance, clearance estimates, et cetera, et cetera. And this is one of the skills that I would tell you that all competent people need to have. If you have a supervisor, lead hand, foreman, safety professional, whatever the title is of that person, they need to be able to look at a job, look at a person, look at the equipment, and ensure that their worker is not going to get injured in regards to force or clearance. So I'm going to touch on this estimating system performance. Again, this is probably one of the more challenging skill sets for a competent person. But once you start dealing with it, it can be much more simple than what everybody thinks it to be. So estimating the performance of a fall protection system is important for the safety of the individual, and it also reveals which parts to correct, and then obviously to ensure compliance. Uh, in that book I mentioned, and in the training that I always conduct, I try to keep it simple for people because there's so many different ways to calculate clearance. All manufacturers do it a little bit differently. I've boiled it down to a simple 3-step process. If you remember this 3 steps, you can go out and in the field and get a relatively conservative and somewhat accurate estimate as to how much clearance somebody needs. You obviously have to know how the equipment works. You have to be able to look at the environment. But to estimate if the person's safe and whether you're compliant, you do these 3 steps. Number 1, estimate the force. And we do that by balancing the weight, free fall, and the equipment in use, the energy absorber in use. Step 2, so if I get a check mark on this, then I know I'm compliant and the person's not going to be injured due to force. Step 2 is I add up all of the length that the equipment's going to add to my fall. And this is where many people, struggle with this, but it's not as difficult as it seems. Sorry, lost my pen. So the required length, step 2, is formally, when you read everybody's books, it's what's called the required clearances. What's your system demand? How far is that equipment going to let somebody travel? Okay. So if I have a, Here I have a worker with a 6-foot lanyard and they're anchored at the same elevation. When they fall this distance here, that's how far they're going to fall before that equipment engages. So if this person was 180 pounds and looking at the way they're rigged up, I've got a 180-pound person free falling 6 feet. That's within the capacity of that energy absorber. So I can move on from step 1 because I know the person isn't going to get injured due to force. So step 2, I just start adding up all the length. I know the shock absorber could go 4 feet. It's probably not going to go all 4 feet because the person's only 180 pounds, but for my estimate, I'm going to assume full deployment because it's just that, it's an estimate. Harness is going to move for a foot. The worker's connected at that D-ring, a foot below their head, so their consideration for their height is 5, and then I add a safety margin. So how much distance is needed? Here it's going to be 18 feet due to the equipment that I'm using, a 6-foot shock absorbing lanyard and a 6-foot worker. So once I've got that, the last step is I subtract the number from number 2 from the environment. I look at where the worker's working. What are they standing on? What are they working on? Is it a piece of equipment? Is it a building? Is it a scaffold? But I'm looking for this distance here. I want to know how high that anchor is from the ground or, nearest hazard. So all of these numbers from step 2 are measured from this anchor elevation. I merely take this number of my environment and subtract it from the 18 feet. So it's not really a complicated process when you boil it all down. People get confused with it because you can calculate from the feet, you can calculate from the worker's head, there's a lot of different ways of doing it. So to put that into practice, I should have staff, whether that's all of my workers or my supervisors, but what OSHA is looking for is who is the person on that site that's responsible for the fall protection equipment in use. That's going to be your competent person. I'm going to jump into it here in the last few minutes. But the skill sets of that competent person, they should be able to evaluate force, and they should be able to evaluate clearance. They also need to have, that's your recognizable hazards, they also need to have the ability and the authority to take corrective action. So if this is my situation, I've got a connector standing up on a beam on the first story of a building, and he's got a D-ring extension and a dual leg 6-foot lanyard connected to a beam climb anchored at foot level, I would just apply my 3 steps. Okay? So step 1 is I estimate the force. And to do that, I have to take a look at their weight. I don't have to get their weight down to the pound. I don't need people, entering into HR situations. Really, the only question that needs to be answered is, are they underneath the capacity of the shock absorber? Okay? And I know there's different capacities out there, but for the most part, this equipment tops out at 310 pounds. So looking at this worker, he's not 310 pounds. It's a full-grown man, but we know we're okay in regards to worker weight because he's less than 310 pounds. The next thing I would do is I'd estimate the free fall distance to see if I'm within the capacity of that shock absorber. So I'd take this height here. He's anchored at his feet. So this is roughly, just again, estimates. If it's a 6-foot worker, he's anchored about 5 feet, and he's got a D-ring extension for 18 inches, so 1.5 feet. And then this whole lanyard is 6 feet long. So he's going to free fall this 5 feet. His back D-ring is going to travel this 5 feet to the beamer, and then he's going to go 7.5 more before that lanyard and D-ring extension become tight. So the free fall distance is the distance a person travels before the equipment begins to engage. That's the distance that somebody is accelerating. They're picking up speed. Free fall is a bad thing. Okay? Free fall is what increases energy as well as the weight of the person. So this isn't good. A 12.5-foot free fall is excessive. Okay? I would compare that to the capacity of the shock absorber. If he's got a 12-foot FF shock absorber, he's probably not going to be injured to the force. But if he's got a lower capacity energy absorber that can only handle a 6-foot fall, then we've got trouble because we're exceeding the capacity of that shock absorber. Then we know that the energy absorber is going to deploy for 4 feet. So right there, I would probably change this situation due to force, depending on what lanyard they're using. There's a few other issues here in the picture. I'm always usually a little reluctant to show a picture to a bunch of safety professionals because they go into all kinds of things. But fall protection wise, we got what's called a dual connection, 2 legs of an energy absorbing lanyard connected to one thing. It's going to wreak a little havoc with the force. So I can't quite predict the force. I could stop that job right there because the person may be injured due to force because the free fall distances are so high. Continuing on with what your competent person should be able to do is we would do step 2 of adding the required length. So hanging off of this anchor, hanging down here, we just start adding up everything that adds length to the system. We got a lanyard for 6. We got a D-ring extender for 1.5 feet. Harness is going to stretch or move for D-ring slide for 1 foot. The worker's going to hang off the end of that equipment for 5. Shock absorber could deploy for 4, okay? And we add a safety margin of 2 feet. So when we add all of that up, the worker needs 19.5 feet from the top of the beam. And that's just an estimate. Looking at this picture, again, I didn't take an exact measurement, but it's first story. If that's a 6-foot worker, I'm probably only 15 feet up. So this is a skill set that your competent person, whether that's the actual worker, safety presentation, foreman, lead hand, whoever you have identified as your competent person, that's the foundational skill that they need to be able to do. Yes, they need to select anchors. Yes, they need to show out people how to don a harness. But ultimately, you start with the 2 basic mechanisms of injury for falls, and that's force and contact with a structure. People need to do, again, what I call estimating system performance. Okay? By going through those 3 steps, you start by, or you can determine whether there's a risk or a hazard due to those 2 variables. And as a general statement, everything else kind of falls into place. Anchor selection becomes easier, anchor location becomes easier, what piece of equipment you should use if somebody starts from a position of force and clearance. So moving into the competent person bit here in my last few minutes, Washington State kind of expanded on OSHA's definition of a competent person. And they made a competent person definition specific for fall protection. So this is from the Unified Rule. And they say a competent person is an individual knowledgeable of equipment, manufacturer's instructions, use, inspection, maintenance, and who is capable of identifying existing and potential fall hazards, and who has the authority to take prompt corrective action to eliminate those hazards, as well as knowing the requirements of the Unified Rule. So there's kind of two main elements to a competent person for fall protection, and they must have the ability to predict both force and clearance. Or let me back up a little bit. The two elements of a competent person is ability to recognize predictable hazards, and then two is the authority to take corrective action. So when we look at fall hazards, a competent person for fall protection, the predictable hazards are obviously exposure, the hierarchy of fall protection as to what are the control methods. If they are using a fall arrest system, this is where I recommend your competent person start. Understand a little bit about force, what generates force, how do I control force, and that's weight, distance, and deceleration. Once they go through that mental exercise, the solution always appears. If they have like looking back at this gentleman, the issue here is free fall distance. Okay, it's an anchor location problem. I've got several problems with it, but once I go through this three-step process, the solution reveals itself. So I can do a couple of things. Using the hierarchy, let's eliminate this. Can I make this connection as he's flying in that next beam for a connection? Can I make that connection from the lift? Does that worker actually need to be there? Number two, can I attach to the column? You know, there's a 6x6 or a 4x4 column there. I can change that anchorage location from foot level to here. People don't like that because it might get into the way of the flown in material, but it's certainly an option that could be investigated. So where I'm going is if you start with determining the force and the clearance, and you have a competent person that does have that skill set, all of the other requirements of DOSH typically fall into place, or at least they become easier because correcting the force and clearance takes care of the two most, or the two, at least for me, the two foundational requirements of it. And then they have to have the authority to take corrective action. The employer must put them in a position where they can stop work, they can run an education session, they can buy equipment. They've got the authority to be able to take care of these issues as they see them. So I've got a few minutes left. That's a lot of information. I know I've been told I talk too quickly sometimes. Hopefully it made sense to everybody. And at this time, I'll just open up the floor if you have any questions about anything fall protection related, even if it wasn't related to the session here that we're covering. Rob, go ahead. I see you have a question.
Yeah, Dennis, I quickly got to jump off here, but I just put a comment. Thank you so much. This is a really great presentation. One of the biggest problems I see in the field all the time. Most people have no idea how far they're going to fall, and they think they're protected, and they're not. So great information, and I appreciate it. And I ask you the same question I ask everybody else, that giving that information and that knowledge that people have, why would anybody still use a 6-foot lanyard versus an SRO?
Oh, well, two things. Thank you very much. 20 years ago, and even to some degree today, what people use as the criteria for being safe is everybody thinks as long as you're tied off, I'm good. And I think we can go a little further than that now and look at the clearance and force. Regarding the 6-foot lanyard versus SRL, it's all about application. There are thousands of applications where a lanyard does better than an SRL, especially when you start anchoring below somebody's D-ring. So lanyards are never going away. They shouldn't ever go away. It's not a safe assumption that an SRL always outperforms the lanyard. It's all about the location. Let me stop
Thank you so
sharing
much.
here. Yeah, you bet, Rob. Reach out if you have any questions.
Definitely be
John,
in touch.
you asked when the next Train the Trainer class. Email me. I can get you a schedule. I have them running a couple times a year, but I'm not going to plug it all here.
Other questions? Anybody else out there? I see some good things in the chat room. We really appreciate this presentation. This was fantastic, Kevin.
Yeah, thank you. I again appreciate the opportunity, and I know it's a lot of information. Fall protection is a huge topic. Reach out to me if anybody has more.
Absolutely.